Hello, good afternoon. This is Piotr speaking on part 11 of Quasar training. And in this chapter, we'll talk about WinCC OA integration of Quasar-made OPC-UA servers. The particular integration model, which I'm showing here, is using so-called cacophony, which is a Quasar extension that helps with the process of WinCC OA integration. So before we start, we need to go through a few preliminary notes. So first of them is, because OPC-UA is very well standardized and Quasar makes OPC-UA software components and WinCC OA supports certain level of OPC-UA, in fact, you don't have to use the procedure which I'm about to show, because since all things are standardized, you can as well take the manual approach and read the WinCC OA manual, and in the end you'll make it work. However, the procedure which I'm about to show is much faster, first of all, so often you need just 10 minutes to integrate Quasar OPC-UA server into WinCC OA, and this does not depend on the system size. So it does not really depend on how many classes you have and how many objects you have. And then it does not require WinCC OA specific knowledge on OPC-UA. And it's about connecting a Quasar-based server with WinCC OA client. So you could imagine that somebody takes a Quasar-based OPC-UA client, which we also will be covered in future, how you can do that in Quasar, with WinCC OA OPC-UA server, but this is actually not the case. So please be advised, this is about Quasar-based servers. A notable restriction to mention might be relevant to whether you come from my employer or somebody connected to my employer or another entity around the world. So cacophony uses one function from so-called Jacob framework for WinCC OA. So if you don't have the Jacob framework, this is not really applicable to you. And I hope you can find a lot of information about Jacob framework on the net. It's generally a framework for WinCC OA for joint controls where a lot of common software is derived, and it's often used in different accelerator or detector communities around the world. So another mention here is that I suppose that many viewers of especially this part might come from, as I said, high energy physics communities, and especially from CERN in Switzerland. And before using this procedure, you are requested to contact your controls coordinators for green light. It's because it might be that your controls coordinators have a different idea of how you should approach WinCC OA integration of your Quasar-based server. So the problem to solve here is that we have a OPC-UA server which is made with Quasar, and we want to integrate this into WinCC OA-based distributed control system. And by saying integrate means we need to configure a connection between the OPC-UA server and the WinCC OA project, such that we have information exchange between the server and the project. And important thing to say is that as of WinCC OA 3.16, which seems to be the dominant version from 2009, there are numerous restrictions regarding OPC-UA, so some of them will be covered later. Most of the things we covered so far in this Quasar training is covered to at least some serious extent. Clearly, the things we will cover after this part, which would be like about OPC-UA methods and things like this, at the moment when I'm making this tutorial or training, are not covered by WinCC OA, just for your information. So if we look at the problem to solve, generally it boils down to the following things. If you want to have a OPC-UA connection to a OPC-UA server from WinCC OA, you need to first of all prepare this connection. That means you need to create so-called internal data points of WinCC OA, which configure settings of the OPC-UA client, so like where the endpoint is, and different connection settings like on security and authentication, things like this. And then you also need to add an OPC-UA client to your WinCC OA project. And then the interesting part comes when you start using Cacophony. So in the Quasar ecosystem, as I mentioned, there is a module called Cacophony, where you generate WinCC OA control scripts, which kind of get the job done for you. So what you do is you use Cacophony to generate those scripts, and then you run the scripts, and the scripts will arrange for whatever is necessary to get your project connected. So I will quickly show how to obtain, I will later on show how to obtain the Cacophony, but now I'd like to also make one important remark. So Cacophony takes some particular assumption on how things are mapped. Quasar classes map to WinCC OA data point types. Quasar classes, this is important to actually get this. So a Quasar class, which is like a type of a real-life object, like a sensor or engine or motor or whatever, this maps to WinCC OA data point type. So there's like one-to-one mapping. Then instances of those classes, so the things that you put into the config file, map to particular WinCC OA data points, DPs. And then variables, so in the address space, which you can see kind of like children of Quasar objects, they map to data point elements, which means DPEs. And then regarding naming, Cacophony takes the so-called Jacob convention, which is that the slash is the hierarchy separator. So if you have a parent and a child object, then in the naming, they will be separated by a slash, and I think an example will follow soon. Okay, so let's have a look at WinCC OA just to have a point of reference where we're standing before, or such that you could synchronize or get aligned with me on this exercise. So here I have WinCC OA, I think, I don't know which version is it, 3.16 patch 15, and I've installed the Jacob framework, the thing I mentioned to you. It should be more or less obvious if you watch this at CERN what that is. And then if you look at what I actually installed, framework core. Okay, framework core is what I installed. So I will start by preparing this project to connect to our OPC-UA server, which we kept developing until previous parts. And by saying connect means establish the OPC-UA connection, right? So no information exchange yet in the sense of transfer variables, but at least establish the OPC-UA connection. Okay, so for your information, I'm about to start the OPC-UA server that we kept developing until part 10 so far. Just a comment, so if you've been following part after part, you remember that we've been playing with restrictions last part, where I said that Airflow should have precisely one object, so I had to fix my config file before I ran this exercise. So if you've been following, just saying to you, use Eclipse and add this Airflow probe under motor M1 and under M2 in Eclipse. In case you haven't done it, I'm just making it easier for you to start the server after the changes. So we start the server. This is our server that we kept developing, and you remember that there is the endpoint of the server gets printed when the server starts, and we'll need this endpoint. Okay, so now the act of adding the connection. So look, WinCC OA, we have sysmanagement, driver OPC and OPC-UA client, and then I create something, and I will call it like, we call this like a smart motor or something, so I will call it just, smart system. Imagine this is the name of our product or whatever. So it's a smart system, and then I say the driver number is, let's say 10. Okay, now WinCC reminds me that I don't have so-called internal data point for driver 10. So I'm gonna find this, and I think it's in driver common. So I need to create this data point. So it would be driver 10, I think. And the second one for redundancy, I suppose. what did I what did I add actually? That should be driver 10.2, like that. Okay, and then, so that's the first thing. You need to start your driver, and so you need to find the number, or you need to decide on what would be your driver number for your OPC-UA client. So let's say it would be 10, and then apart from the driver common, I think I also need OPC-UA internal DP, which matches the driver number, so will be OPC-UA number 10. And that should be enough for the moment, I think. So now I'm again saying that smart system is at number 10. Exactly. Now it's much better. And here we have connection and URL. And I think this is where I put my endpoint. I wanted to use some dirty word, so by just abstaining last moment. So this is my endpoint URL, which I'm adding here. And I say it's active. No redundancy, nothing. And then I think I'd like also to add a subscription, which we need to use later on. So first we do that, and then we say manage. And I like the convention when subscription follows the name of the server. So I would call it system _ subscription. Okay. And I'm saying it's active. And there's some, by the way, here you find a couple of settings which often will need to be changed. But this you should actually, discuss with your controls coordinator. Actually, the whole thing might have settings that might need to be changed. Okay, so this gets saved. And as well as that thing. And then if we get back, okay, so we have the internal data points, right? So the next step is to actually add the OPC-UA client in our project in the Pimon. So we find something which is called append in new manager. We find OPC-UA, and this is somewhere here, and with the number 10. Okay. And maybe I keep it manual because I want to have some control on when I start this project or not. Okay. Voila. And then we can actually try to start this server. And let's see what happens. And it told us, okay, we have some certificate issue, but that's expected for completely different reasons. I will not get into this at this moment. But the message of interest is that we are connected. We are connected to OPC-UA server, the one we made with Quasar and Open 62541 backend. So let's keep on moving. So now I'm leaving WinCC OA for a short moment, and I'm going back to my OPC-UA server project, and there I want to clone. So I mentioned the cacophony as a Quasar extension, Quasar module. So it lives like Quasar itself on GitHub, and I want to clone it. So I copy its link. Then I go to our root of the OPC-UA server project, and I do git clone that thing. Okay, and essentially we're ready, because at this stage, if you clone it in proper path, cacophony is entirely ready to take Quasar's design and to do what it should do, which is cacophony generates stuff. Actually, already did what we wanted, but I wanted to show you what are the possible options, because they are important. Look, so when you run Python cacophony generate stuff, it will create the control scripts that you will use to get your stuff done. But the scripts themselves it's actually much easier to use if you give a bit more of information, which is like what should be the DPT prefix, server name, driver number, subscription, function prefix. So I would like to actually show you one by one how to do that. So DPT prefix is simply the prefix that will be prepended to the data points. And since we said smart system, I will keep it smart system, but maybe nicely written like smart system, okay? Which means that if we have a motor class in our Quasar design, we'll have smart system motor, okay? It's really nicer to have this prefix to do something like a namespace, because there are really no namespaces in WinCC OA. Then the server name, we said should be smart system, I think. And the driver number, we chose it to be 10. And subscription was like smart system subscription. Okay. And function prefix, okay, I will pick something. So this is maybe less, no, I will not actually use it because this is slightly less relevant at this moment. So I will keep it default. Okay, so I run this. And look what happens. So it tells us that in the directory cacophony generated, so let's go there, we can see some control scripts. Okay. For instance, config parser. Okay, it's rather longish script. And create DPTs. Okay. Okay, so we look inside generated, what we find is those control scripts which I was talking about. And what we're gonna do right now is I will copy those scripts into the libs directory of the project. So what I do is .ctl into where my WinCC OA project is, which is actually there, into scripts and libs. And I think it's there. Okay, and then if I look here, libraries, and now I find my two of my CTL scripts. Okay, so then the next thing I will try to do is I will try to execute those control scripts. So one thing I really hate doing is actually creating a panel to do that. I really hate it, but I don't think there's a better way in WinCC OA. Of course, I could edit the script and run it via control manager, but God, please help me. Okay, so create DPTs. Okay, and yeah, okay, new panel. It's for demonstration purpose. So what we want to do in this create DPTs is actually to run this function create DPTs. Okay, so what I will do is when it's clicked, create DPTs control. Okay, and then I do simply create DPTs. Voila. I believe it's correct, but we'll see. So what I'm showing you is the most default way of running this. So create DPTs, I save this panel, I run this panel, and let's see what happens. Did anything happen actually? Okay, I think it did. It simply printed nothing because it went fine. So what are we expected to see is now I open para, and I told you we had this DPT prefix that we configured, right? And we said it's smart system. And look what we see here. It's smart system airflow probe, smart system controller, smart system motor, and smart system temperature probe. And those names are here because, well, those are our Quasar classes. Okay, so now we have DPTs per Quasar classes, and you can actually see they don't have any DPs, but at least we are one step forward, which means now in our WinCC OA project we have appropriate DPT classes. And if we look at how would that be actually? If we look at our motor, for instance, then we also see so-called DP type elements. So we see that all things like all cache variables that were exposed in the address space of the server are already known to WinCC OA. So in one of the next steps, our task will be to actually create DPs and then to make the connectivity. Okay. All right, so we finished. All right, so now let's move to the application of to the application of the other script, so of config parser. So if I open the script, what I see is I have a function called parse config. And this function takes config file and then create DPs and assign address and continue on error and few default arguments. And in parse config, the primary argument is the config file name, and this config file name is precisely what Quasar uses as the config file name. So it should be the identical file name as the one you use to run the Quasar server, for which you make this connectivity between WinCC OA and that particular Quasar OPC-UA server. So to be even more precise, you remember that that was our server running, so we used the file called config.xml. Okay, this is our config file, and to have a nice way, I will need the path of this file, so that's where I'm running this. So this is my path, which I will copy paste in a second. Let's prepare to run the other function. So I create another push button, and this will be parse config. In fact, it's beyond. So it's parse config, create DPs, assign addresses. Okay, looks a bit ugly, but fine. So here I do as uses config parser.ctl, and then you remember we have a function parse config. Well, maybe let's take this, let's copy paste this just for to remember what arguments we have here. So you have parse config. So config file name. What will be the config file name? As we checked in the terminal, is that so precisely the same config file that I created in Eclipse and I was using to start the OPC-UA server of our development. So parse config, okay. Then a few yes/no questions. So like whether we want to create DPs, and the answer is of course true. Then whether we want to assign addresses, and the answer again is true. And whether we want to continue on error, okay, let's say it's true for the moment. I'm not entirely sure if this is what I advise you, but... And then we have two other arguments that actually I will, of course, skip at this stage. For your information, they actually are likely to be used by you in future, but for the basic mode, and especially if you just want to connect one WinCC OA project to one OPC-UA server, you can just remove them, okay? Voila. Which means I should probably ready to run it. So I will restart my OPC-UA server. Beautiful. And then I go to Geddy and I save this and I run this panel and let's see what happens. And it said, okay, a few debug messages about coming from inside the script, setting active, blah, 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 blah. So it looks like, it really looks good. It really looks good, and I'm quite happy. And also what we can see is it tells us that the subscription that we once created by hand, you remember Smart System subscription, was successfully created. You know, so which means that it was actually used to perform information exchange, and I actually expect to see the information from the OPC-UA server in WinCC OA right now. So what I do next? So now I'd like to verify if there is actually the connectivity. So what I do, I go to Para, and there I find Smart System Controller. Now look, I unfold this, and now I see the particular instance here. So this is the effect of running parse config. And this instance, of course, comes from the Quasar config file. But this instance doesn't have any attractive variables. But you remember we had motor, and now we have controller 1, motor 1, and there is rotational speed. And guys, look at this. So now we really have information exchange. I can run my WinCC OA UA expert, sorry. And I connect to this, and I find controller motor 1 that was rotational speed, I think. So this is like randomized, or like not really randomized, but you know what I mean. And okay, there is of course a factor of time delay, small time delay, but you see what I mean. This is reflected. So we kind of reflect now in WinCC OA the information coming from OPC-UA, which means you can start using by dp-get or dp-connect this rotational speed and enjoy profiting from the information that comes via OPC-UA from a Quasar-based OPC-UA server. Now, what is important to know is, especially if you don't know how WinCC OA works, so we use the term assign addresses. So assigning addresses means you assign some so-called config. In this case, it's called address. It's the way WinCC OA approaches communication with anything what is external to WinCC OA, like OPC-UA. So if the address is assigned, like here, so you remember, for instance, in controller there was like no peripheral address, right? Or was there? No, I don't think so. But because there was no variable, of course, because this is an object, so there was like no DPE. Here we have a DPE called rotational speed, and it has a peripheral address called address. And the whole information that is here is, of course, matching our choices. So it's matching the server, matching the subscription, the driver number is correct. The item, control1.m1.rotational speed, this, of course, corresponds to, look at this, control1.m1.rotational speed. If you look at UA expert, and if you go to rotational speed, and you look at node ID, you will see precisely the same thing. So namespace index 2, then the string identifier, so what WinCC OA prefers to call like S equals, is control1.m1 rotational speed. And if you didn't use cacophony, you would have to derive this information all on your own. Okay, so that's where the cacophony shines, that it actually does this automation for you. And then it says it's an input. Unsolicited means it goes on a subscription mode, so whatever changes on, it means that client kind of samples what is in the server's address space. I'm not really going to the details because those are quite intricate, but understand that this is like a way where client kind of gets notified by the server when anything changes. Now, another important thing is I told you that there's this called Jacob convention. So the name of this DPE has a slash, control1/m1, and this fits the Jacob applications. Of course, if you work on an application where the DPE should be called differently or the schema should be different, you of course are free to contact me. So we could extend cacophony with giving a custom option to actually decide what's the separator. So let's move on. There's one more very relevant thing here. So we set the rotational speed, and that's by Quasar design is of course input only. But then we see rotational speed set point address is in-out. And why? Because Quasar design, we said that this should be in-out, so cacophony knew that, and it of course pushed that into this config. So what I'd like to do now is I'd like to see if I can actually. So here I subscribe to our rotational speed set point in the server, and what I'd like to do is I'd like to write something here, and yeah, you see. So I wrote in WinCC OA, and then I see the value in in UA Expert, which means it was transferred to the cache of the server because it was a cache variable, and then you see this information reflected in another OPC-UA client. One more point of attention here. So look what happens when, okay, this may be less important, but look what happens when you remember when we've been doing the device logic for rotational speed set point and demoter class, I think it was, I don't know, part 4 or 5 or something, we coded it such that if the value gets insane, it will be rejected by the server, right? So, exactly. So this is here, write to node, blah, 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 but out of range, which means, we cannot spin our motor to like 10,000 RPMs. So what I'd like to do now is I'd like to see what happens when I do that from WinCC OA. Let's try. So I'm saying 10,000 and look, this is the thing I said about that WinCC OA has very relevant restrictions on OPC-UA, and this actually precisely what this actually happened. What I really demonstrated this restriction, which means let's do that again. So I'm writing 10,000, and of course I get the information in the log viewer that you cannot write to the node, and probably you also that the status code is bad out of range. But for some time, first of all, I don't see this error on the DPE, and the second of all, even the value stays like wrong. It thinks it's 10,000 and it corrects itself only after some time, which is probably some sampling time or whatever. But to my understanding, this is a major issue of WinCC OA, which I was talking to the company, and a few of my friends were talking to the company, and nobody takes this seriously, and I really need to speak up on this, because this, in my opinion, prevents serious applications of OPC-UA in WinCC OA. It's my private viewpoint, but I have to warn you that you have to double or triple think on what will happen when from your control system you'd be writing things and you cannot catch if the write was successful, and there's even misleading information on actually that value stays wrong. This is all due to the way WinCC OA architecture is. I know there might be something coming on in future which would be much better, but still as of 2019 or 2020 actually, there doesn't seem to be a right solution. So then, of course, if you write your scripts using dpset and dpget, the same will, of course, happen. I mean, you will be able to do dpset for any value, and then you will stack. Okay, so I believe we went through all the basic points of using cacophony. So now you saw how you can integrate stuff from Quasar into WinCC OA, and of course, as your system expands, you will need to maybe run those scripts again or regenerate the scripts. And for the moment, we don't seem to have any better way of doing that. For instance, we cannot do deltas. You can, for instance, remove all your DPs and regenerate them again when your system grows, or you can only create the new ones, but this would involve some manual work. Maybe one more thing to add here is when the connectivity of your system is gonna grow. So for instance, you will have one WinCC OA project connecting to multiple OPC-UA servers made by Quasar of the same type or not of the same type, that actually it matters. You will need to use some more advanced features in here. So for instance, this connection settings is where you say what would be the name of connection and subscription name and the driver number. And of course, when you have multiple OPC-UA servers, you will need to have multiple connection names. So then you will be able to actually use this connection setting mapping and put the relevant information there. And this is actually pretty well documented if you look into cacophony/doc, I think. there you will find some information how to profit from that. Yeah, exactly, this one. So Cacophony Framework Quasar, you will find this information there. Also, for your information, look, the script that we're looking at is called config parser, and the function is parse config. You remember when I was running the Cacophony generate stuff, I skipped exactly. I skipped the function prefix, right? I said it's not relevant at this moment. It's really not relevant because now the function is called parse config. But when you have multiple deployments of different Quasar servers into the same WinCC OA project, of course, you will have to use this function prefix. And for instance, use this function prefix smart for this and maybe something else for something else, because otherwise you will have a conflict of naming of functions. You will simply have multiple parse config functions, right? So this you have to pay attention to. Okay, so I hope this was fine. Feel free to post questions on the YouTube or contact me directly. I actually like questions on YouTube because then also the community can see what sort of problems were already solved. So I hope this was useful, and we'll carry on soon.